Hello, good morning, and thanks for joining me in my shop here. It's April 4th, and I'm ready for another day with this radio. Right at the end of the last video, I discovered the local oscillator wasn't operating. That's kind of what's been going on and off with this radio as you tune it. I believe the oscillator's been coming and going. And is it because there's still shorts in this capacitor? I kind of don't think so. But what else could it be? Giving these guys another clean up here. Have a beautiful sunny day outside. And as I'm standing here, I'm in a bit of pain. I cracked a rib or something like that a few months ago. Couple months ago, and did something to it anyway, and it hurt for a while. It went away. Yesterday it flared up again, and I sure hope I don't cough, because wow, is it painful. So don't know how long I'm going to last today even doing this. Just seems lovely and smooth. Okay. No local oscillator. If it's not because of the capacitor, it's possible it's due to other capacitors. Have a look at one of them in here. Just let me. Yeah, you're gonna hear me moan and groan a little bit today, I think. Yeah. God help me if I sneeze. Oh my gosh. No sneezing allowed. So this capacitor right here, you can see it in the camera, right where the wire comes out. It looks just a little bit whitish. Let's take a closer look at that with the other camera. Unfortunately, the autofocus is on here, so it might take a moment. Autofocus. Terrible. Well, it's clearly corroded on the top. This black cover that is so common in these radios, I believe it off-gases a little bit. And some kind of corrosive gas comes out of it. Don't know that for sure, but what happened? What happened to this capacitor? And is that corrosion kind of crawling its way up the lead wire inside the capacitor? Is it coming out of the capacitor? Anybody else show stuff like that? Ooh, that's bent pretty sharply. You don't want to wiggle the lead ends coming out of these capacitors too much. That one looks like a little bit of corrosion there too. Anywhere else in here? It's just curious to me that it's on that one spot, and you don't really see it happening anywhere else. Huh. Yeah, I don't know. Now, the condition of the capacitor is a little bit interesting too. In the camera you can see how greasy and shiny it looks. There's another one right beside it. It doesn't look shiny and greasy at all. And there's another greasy one over here. Now is that telling us something? Is that saying, hey man, I got hot? That's why I'm all greased up? If it gets really hot, it's going to drip or run. The wax is going to drip or run on it. I don't know the answer to that question. This guy, he looks a little sweaty, is what he looks like, but it doesn't look greasy like this. Greasy, sweaty capacitors. If you look, well, I was going to say, look at the stuff that's all over the bottom here. Yeah, it's dripped. Of course, the radio's upside down right now, so it wouldn't drip up. It would drip down. So this would be where stuff would collect and get ready to drip off this end here. Looks a little bit like that. Looks a little sunken. Looks odd. Actually, the end of it does look a little odd. I don't know. I just think that's a curious thing to look at. Okay. Enough curious looking. Hey, let's look in here while we have a chance. I'd have to force the focus, especially a pattern like this seems to throw the camera way off when it comes to focusing. So let's do that. Let's just take a look in there. I'm just gonna bear with me a moment here while I basically turn off the autofocus and force the focus right up. How about like that? How about like that? Okay. Oh, they look much cleaner. Much cleaner. Still a little bit of stuff on it, but I don't see crystals reaching out. Yeah, it looks pretty good. Very good. Okay. I'm going to give the radio another try. And the reason is I have cleaned those plates a little more. I do want to investigate this lack of local oscillator problem. Although it could be I'm at the point now where I just start changing out capacitors, maybe selectively, instead of looking for non-capacitor type problems. Okay, let's operate the radio. Volume down. Plug is in. Away we go. Now I believe the antenna is, I'm sure the antenna is switched off. That's okay though. So hear that? Swoosh swoosh? That suggests the local oscillator is operating. All this, the local oscillator is operating. Well, that's interesting. It's working. It seems to be working quite fine now. Could be there was still a short in here, and this morning I was plunging it deeper with the feather, and I cleared it. Maybe that's what happened. Hockey, hockey, hockey. Well, that's great. Okay, we're going to shut it off. That's fantastic. I think the last little bit of cleaning you saw me do knocked off the last few of those, I don't know what to call it, fur, knocked the fur off. I have seen radios, and this is a common thing, with galvanized, I think it's galvanized steel parts, and the large, very fine, thin crystals grow. They grow perfectly straight. They're straight crystals. They grow on different angles, though, and they're very tiny. They look like metal fur when you first see them. Some of them would be quite long. Could be that long. Most of them are quite a lot shorter, and it's quite obvious something's going on. I think the same thing has happened in here. Right? Something like that has happened. I really do believe we're looking at some kind of growth, crystalline growth on there. Don't know though. I don't really know. Don't know. Okay, I'm going to take a little break, and then we're going to pick on some capacitors to change. and start fixing up this radio. Fantastic. Can nothing be straightforward? So here's a package with a capacitor in it. It's oh my, it has been opened. I was going to say it has not been opened. So it says on the package 0.1 100 volts, but the capacitor itself says 0.1 400, and it looks like it's come out of something. Let's give this guy a test here. Looks like it came out of something, but the leads are new, so no, I don't know where it's been rolling around in somebody's dirty junk box or something. It's been in a plastic package. So it comes out to that would be almost exactly 0.1. That's good. This is a good capacitor. 9,900 nanofarads. Good. That's a 0.1. And I'm going to put this in place of, and I really haven't mentioned which, this big, I'm going after the big guy first, this big one down here. Okay, let's get it out. There we go. It says 0.2 on it. Really? Yeah, it says 0.2. Huh. Made in Canada. 0.2. It's a little bigger than what I've got here. I got a 0.1 because I thought it said, well, wait a minute. Maybe I identified the wrong capacitor on the schematic. Look. Okay, we're all set here. Watching the pi on the eye. What's it do? It's not going to open. So a very leaky capacitor, and this one is a bit of a safety capacitor, in fact. 0.2. Uh-oh. That's a bit of a problem. Okay, 0.2. I'll see what I can find. Dig around through my parts some more. I guess I'm going to have to invest in some new capacitors because this is really getting to the bottom of my box here. This is a 2.2 NOS capacitor. It's filthy looking, but it's actually not. Let's just see. I think it's a very high quality capacitor the way it's constructed, so I bet you it's just fine. Let's see. So this says it's a 0.27 instead of a 0.22. Usually when these read high, it's because they're leaky. Can this be leaky? I mean, it's a really solid looking capacitor, but I think we better test it. 50 volts. What do you say? Okay, 150 volts. It's not particularly good. Nothing special about this capacitor. You take out one leaky one, put in another. It's better than the one that was in there. It's in a circuit location where a little leak doesn't matter. Oh, I gotta decide what to do. Tell you what I think I'm gonna decide to do. I'm gonna stop because my back is killing me. Yeah, my back is sore. I got this rib in the front here that's sore. I'm sore and can't stand standing up. So I'm going to stop for today. It's a beautiful sunny day. I'm going to go outside and enjoy that. And carry on with this some other time. And through the magic of video, 24 hours has gone by. And voila, I have changed the capacitor in here. So it is the next day from when I started this video. Yesterday was just too nice a day to let go by, and today, nah, cloudy and rainy again. So, okay, so I have the replacement in there. That leaves 1, 2, 3 more wax ones to do. There's one here that I pointed out before had some corrosion on it. Let's look into this one. This is hooked up to one of the IF transformers. I think the first IF transformer, and the other side, I'm going to guess that's a ground terminal there. Let's find out if I can. And my voltmeter is in another room. I gotta go get it. Okay, gotta repeat what I just did because I had a video making error take place again. So we're just checking to make sure that this is a ground point over here. I've already done this, so I already know the answer. The answer is no, it's not. It's not a ground point, and the other end certainly isn't grounded. So, okay, capacitor does not go to ground, goes to the terminal on this tube. This is the 12SK7 IF amplifier tube. It's pin number 3. So you have 2 capacitors, and there's a resistor hidden down here hooked up to that pin number 3. Pin number 3, look at because the schematic does not have pin numbers. 12S 12SQ7. Pin number 3 is the cathode. Pin number 3 is the cathode. That's commonly grounded, but maybe not in this radio. Pin number 3. Okay, let's look at the schematic. See if we can sort out the capacitors there. Okay, so we're looking at this tube. Pin number 3 was the cathode. Oh, there's nothing. There's nothing here. I didn't notice that before either. 100 ohm resistor here. Well, this is something's gone wrong here. I could see capacitors being connected to this end of this resistor because it's a ground point, like this capacitor could be connected there, like, you know, it sort of is. 0.1. There's one kind of large one here. I don't know if it's a 0.1. I can't see the value of it. Okay, let's look back at the radio here. A lot of humping and hawing. Actually, there was no hawing, just humping. There's another one. How many humps have you got? Well, let's get a pointer here. I'll use a glass rod. So I think these two are connected here. They certainly are. I mean, I can see it quite clearly. This is definitely 1, 2. It's definitely pin number 3. That would make it a cathode. Now there's a resistor under here. And that's a body end dot. Brown, black. Can't see the dot. There's another corroded wire here, right here. Again, coming out of this black stuff. So, you know, what is going wrong here? Let's measure that resistor. Is it 100 ohms? Looks like it could be. It's 100 ohms. Why, Oh, my fault. 12SQ. No, 12SK. 12SK7. 12S. Back over here again. 12S. Okay, down here. Okay. Pin 3. Pin 3 here is the suppressor grid. Suppressor grid commonly tied to the cathode. Suppressor grid. Well, then in the cathode, I bet you the cathode's 5. Yes, it is. Okay, that all makes sense now. So now, spun this all around. So we have cathode resistor coming down to suppressor grid terminal. Suppressor grid terminal is normally at 0. So often it's connected right to the cathode, but not in this case. This has got to be a grounded point. You know, I measured it to the chassis, and I should have measured it to the B minus. Yes, mistakes on top of mistakes. But I've sorted it out. Okay, so now we have 2 capacitors finding a ground terminal here. One of them is on pin 6 of this tube. Pin 6. That sounds like a plate to me. Why would it sound like a plate? Pin 6. Pin 6 is the screen. Well, close to being a plate. Pin 6 is the screen. So I have a capacitor hooked up to the screen terminal on the SK7. Let's take a look. And so if we take the screen, voila, 0.1 right there. So we know which one this is. 0.1. That's got to be this. Whoops. Whoops. Got to be this guy. 0.1. Got to put another capacitor order out. They don't stock large capacitors to any great degree, and I run out of them. I see a little more green in there. I wonder what that's all about. And what I'm talking about is corrosion of some copper materials. Why are some corroded and some not? Capacitance. Another job for the Swedish fish knife here. Capacitance. Written down. There it is, 0.1. Yeah, there it is. 0.1. Okay, I'll find a 0.1. Stick it in there, then I think we better operate the radio after doing 2 capacitors here. Okay, let's give the capacitor a test. This is the 0.1 capacitor. Okay, test set is warmed up. 50 volts. Watching the eye here, if I can just shade it a bit. Here we go. Closed. Closed for business. It's not coming open. So as capacitors go in these old radios, this one and others have tested worse than average. When the eye doesn't open, it's at the limit of the test set here, and you really can't make a judgment on just how bad it really is. It's pinning the meter, so to speak, so we don't really know how hard. But bad, that's a bad capacitor. Here's the one I've put in. We have 2 wax capacitors remaining, and there could be resistors that are out, and mica capacitors could be defective, although very unlikely, very uncommon. Certainly does happen. We're going to give this guy a test, and I've got to go turn on the antenna. Okay, let's give it a go. We'll make sure it's still operating. Volume down. Still have a ground to the B minus here. Going to my voltmeter, got the antenna connected. Good. Here we go. So I don't know if I mentioned it. I think I did on the last video that I've hurt a rib in my chest. That's where my ribs are. And boy, oh boy, if I cough or sneeze, or if I sound like a cat, it's because of this rib. Isn't that right, Shadow? Yeah? Oh, I hear a radio. Quite a hum there. Volume's right down. Wow, this thing is just... It's too hot. She's too hot. A lot of noise here. Let me put the... well, I can't hook up... This is where the disaster would happen. If I could only turn this down a bit. Oh. That's sort of turning it down. There's a hum there. It sounds kind of shrill. So there's, in the guy's voice, there's clicks. So there's kind of like a sparky sound in here, but I think it has to do with the signal, the sound signal. Very shrill. Okay, so the way I interpret that, and I'm just taking wild guesses here, is the impedance of the grid to the triode has gone too high. And how could that happen? Well, I mean, just wild guesses here. The capacitor that's inside this shell, which is no longer connected. What happened here? Well, there's a screw missing. Maybe that wasn't grounded just now. Yeah, the screw is missing from here. Did I take it out? I don't think I took it out. Huh. How do you like that? Let's put the screw back in and try this radio again, because with this shell not grounded, if it was actually stood off from the chassis, then this thing becomes an antenna right in the worst place. Let's see if this will work here. Oh, well, this has been moved a fair bit. Yes, Peanut, Shadow. Oh, Peanut, no, Peanut's not with us anymore. Look at this. Shadow, what is it you're after? You want to go outside, I bet. This is loose here. I guess you got to screw it in from the other side. Okay, that's good enough for a test, because I can move this around and we'll find out what's going on. Wow, that's really loose. I think I might have some trouble getting the wrench in there. This is good enough for a test. This is good enough. Solder looks fairly fresh here. I don't know what to think of it. Okay, try again. Here we go. Shadow, you giving up on me? She's outside now. Outside the shop. Okay, power back on. So just to be clear, the buzzy sound I was hearing could have been coming from this not being grounded to the chassis. I doubt it, but let's find out. I think it's making any difference. Oh, it does. Oh, Shadow, just hang on a second. Things are exciting here. It's a minor difference. Okay. Okay, Shadow. What do you want to do? Do you want to go in the garage? Okay, we're going to go down the hall. If we go to the left, that's to the garage. Come on. Come on. Which way? Which way? You want to go up here? Okay, she wants to go upstairs. Obviously. Okay, let's deal with this guy here. Now, if this capacitor has lost its capacitance, then I think you would get that buzzy hum. You'd get perhaps a shrill sound like we're hearing, but you get lowered volume, not raised volume. So, in the past, I've managed to pull the capacitors out of these things. Let's see what happens here. This is the input. Often these capacitors are on the output. No, I don't see one on the output. Okay, you can see a shielded cable here. Just a little extra safety there. Looks like it's really in there. What's that? So probably to get this out, I'm going to have to unroll this a little bit. because it just looks like it's fused right in there. Some of these, they just, I've had them just kind of fall out. Let's see if my little vise can do the job here. Yes, I have a little vise. I'm not all pure. It's always good to have a little vise, I think. Whoops. Another job for the Swedish fish knife. Wow, that's a good knife. Holy smokes. There it is. It's unlabeled. It looks a little bit special. Let's look on the schematic and see what we've got here. So this is the input to the volume control. Here's the volume control. Ooh, is it this one? Wait a minute, that doesn't make sense. Wait a minute, shielded. It's the output. What am I looking at here? Well, this is a little odd. So this is 0.005 shielded. That's typically where these capacitors are, but in this circuit, it appears to be in here. That's a big difference, because if you have it the way this is shown, then the DC coming out of here has a choice. They go this 5 meg way or down through this, which they were 1 meg. So you go 5 megs this way, 1 meg that way. In parallel, the two of them make like 750K. But if you stick a capacitor here, then DC wise this is the only path, and now you're forcing down through 5 meg ohms. That's quite a difference in what's going on up here. Like what this is facing is dramatically different. I don't think I've ever seen a capacitor over here. I probably have. Now look, now off of this there's a moderately sized shielded one, and then a very small one here to ground. This is probably trying to sneak off any RF that might still be there. Very large resistor here, 10 meg ohms. They're always big in this position, but that's really big. These are all really big resistors. So what am I supposed to do? Am I going to move this capacitor into the position shown on the schematic? Is the schematic on the bottom any different? No, the schematic taped to the bottom of the radio is no different. Then maybe I'm making a bad observation on the way the radio is wired. Let's look again. I'll get the other camera. You can look too. We will see. Okay, just one last look here. So we have the output from the radio circuit, the RF and the audio coming down here after being detected by the diodes. It's coming down here. Some of it is shot over through the volume control and goes to ground. All DC traveling in here. On this schematic. And then quite clearly the shielded capacitor is sitting over here. It's quite clear. There's another capacitor here. You know what? There is a small capacitor right here. This one right here. So that's got to be this one. But now we'll look at the radio. So here we have the input signal. Well, I don't know what we have there. I'll take that back. What do we got there? We want a signal coming back from the detector. What is this? So here's the detector tube. The two diodes are soldered together. There they are there. Other side of that coil. the secondary. I can't figure this out. There's be a high voltage here, heading to here, showing up here. Oh, that doesn't make sense. We don't want a high voltage there. Okay, not making sense here. I'm not making sense. That's what's happening. We should have an output coming from the slider through a shielded capacitor that doesn't appear to be there, and then heading up onto a tube pin of the SQ7. That's the triode grid. The SQ7. Now's my chance to look at the SQ7 on here. 12 SQ7. The grid is pin 2. Pin 2 on the 12 SQ7. This wire is coming up to, this is pin 2, and the wire's hooked right onto pin 2. So for sure, this is the output line. The output, did somebody switch the wires around by accident here? Because the output should be coming from the slider. But the slider's hooked up to this. This is hard to follow. It goes along, comes up onto this single terminal strip, not grounded. Oops, sorry about that. Hey, stand still there. Don't get so excited. Comes up to this terminal point. Heads. Yeah, this would be the output. This would be the output from the. This would be this point. Right here. We're looking right here. This, it comes out through a resistor that's 33K, so it's orange, orange, orange. You can probably see that in the camera. Orange, orange, orange. Right there. Very good. So the output's coming out. It's tying to this terminal strip where it's picking up the shielded wire. The shielded wire is then going along to the slide. Like, am I getting this wrong? Is there another terminal on this volume control? I said something about using the close-up camera. Let's do that. Even though I'm probably gonna have trouble with the focus, but radio's unplugged and all that. Just sit it in there like that. What do we see? Like, am I crazy or something? Is this radio wired backwards? It appears to be wired backwards. So looking at the volume control, I see 3 terminals. 1, 2, 3. I see the bare ground wire going right to the switch in the back where it's picking up the B minus. It looks like a really clunky soldering job. It's okay though. So this is going to what we could call the grounded end of the volume control. And then you have the slider in the middle. And then we've got, there's no chance that this is volume control is built differently. I've never seen one built differently. I think these wires are wrong. But look, this wire doesn't reach, does it? Can you reach? Could somebody have accidentally mixed these up? What were they doing here? Did they change the volume control? So one way to tell if the volume control or controls changed is look at the lineup here. They line up pretty nicely. Is this fresh cut? I don't think so. Is this flat area ground in? Well, I don't think so. It might be. This might be ground in. This might be a replacement volume control. It might. Is there any way of knowing? Well, I'm gonna have to assume that this has been done wrong. How can you possibly extend this green wire? I guess you could. What's the solder job look like back here? Well, that's not looking very factorish, is it? It looks like I soldered this stuff. That's what it looks like. I think that wire's gone to the wrong spot. I think it's supposed to go up here, in this spot. I'm going to change it. And then that would also relocate the shielded capacitor onto the... Is this one? Yeah, you know what? I think somebody made a wiring error here. I think somebody, for some reason, fiddled around there and they got it mixed up. Okay, I can't say too much because it happens to me too. So I'm going to correct this. I'm going to move the input to the volume control wire to the top of the volume control, and the output on the slider to the output wire going to the triode, and stick in a capacitor inside the sleeve. That's what I am going to do after some coffee. Okay, here's the replacement, a little smaller. There's probably no need to do this. These capacitors have an outside foil because it's two foils wrapped in a spiral. Inevitably, one of them ends up being the outside. And the outside foil on a lot of capacitors, the capacitor tells you which one, like this capacitor, this bar is telling you this wire is hooked up to the foil that ends up on the outside here. And that acts as some shielding to some degree. This one doesn't tell you. And I tried a few things to try to determine which is the outside and which is not. With mixed effects, it's not very easy to tell with these capacitors. I find, anyway. See if I can do this. I don't know if I can even wrap this back up. A little easier unwrapping it. I don't know. I may forego this. Let's see what we can do here. Oh. That's not bad. Actually, because this end's a little pinched, this end's a little wider. The capacitor went in and kind of jammed in there nicely. What's going to happen if I leave it like this? It's going to be sticking out there a little bit. Samson-like strength here. There we go. I certainly don't have his hair. Okay, better put some covers on that. And the other one, do I have another? Here's another piece here. Here we are. Any idea where the screw went I was using? Could be this one. Yeah, this screw has to come in this way. So there's no way I took the screw out. Somebody else took it out. I think what this looks like is the volume control got changed and a wiring error was made at that point. That's what this looks like. And how this, can the guy who did it return this to the owners in the condition it was in? I don't know, because it seems to me it has very big consequences. Here's another screw. Namely the volume control. It doesn't go to 0 anymore. The shrillness. I don't know. How could somebody make that kind of mistake? I can start this. Pretty awkward. There it goes. Oh. Okay, it's just starting. Okay, tap a new hole in here. Wow!
failing. I'm rounding out the screw here. And I'm sure the next size down is no hope. Chance of doing it with a screwdriver, I doubt it. I don't think it's going to work. The angles are not right. Okay, take it out of here. Maybe what we'll do, I'll find a nut and a bolt to go through. That's probably a better way. Okay, nut and bolt. We'll do it that way. What I do here is I keep a set of nuts and bolts put together, so I don't have to find a nut and then a matching bolt. That's a biggie. That's a biggie. Let's see what happens when we get it through the hole here. Probably not. Wow, it's close. A little too big. Okay. Something a little bit smaller. This is going to do it, I think. Nope. Something smaller yet. A bit too small. This was definitely small enough. That's not that bad, you know. It's got a lock washer on it here. Let's put the lock washer here. And can I find another little lock washer? Okay, this is going to work. A nut at the back or at the front? Nut at the back. And hey, where'd that capacitor go? What happened to it? I've lost it. Here it is. Now we can put it upwards. I think that's pretty good. I like that. That's below the apron. I just dropped it. Where'd it go? It disappeared. Rats. Let's see if I can pick it up with this. Got it. Did I drop it again? It's on there. Definitely time for me to go to the optometrist. I'm probably 2 years overdue. Okay, nice little screwdriver. Okay, that's not coming loose. Very good. I'll hook up these wires. This one to the output. I have to undo the ones that are in there. Okay, I'll do the wiring up, and then we're going to give it another test. So in doing this, I've made the situation very close to developing a dangerous kind of short circuit. So I have the camera here to look at it, and I'll just show it to you. It's the kind of thing, it's a little hard to see in there, and you could easily overlook this kind of thing. So we're looking at the photograph. You can see the shielded wire coming up with the coiled shielding wire wrapped around it. It ends. The green wire's coming out. Right to the left is the big brown capacitor with its lead coming out. That brown capacitor lead, it's not a capacitor lead actually. This is not a capacitor lead. This is what I'm talking about, though. This wire runs from the basically the outlet. This terminal I got my stick on it's got 120 volts on it, depending upon which way you plug the radio in, and that is carried up on this wire. This becomes the B minus, if you like, and it's hooked up to the bottom of the volume control in a very typical way. That's where this is going. But look at the shield. Look at how close it is. Now the radio is upside down, and it might look like, well, it doesn't look good to me, but somebody might say, well, that's clear enough, isn't it? And then they turn the radio right side up, and the green wire sinks just slightly, and you get a contact right in there. So I am going to clear this a little bit. And now this wire really can't move very far, I don't think. I can move around a bit. But that's not going to generate a short now. But it's still fairly close. And I look at it with my own eyes, it looks very good. It doesn't look close at all. In the camera, it's a little hard to tell the dimensions of things. So there we are. So I have it done. So I have, no I don't, I still haven't hooked up the other side of the capacitor. We're not going to hear anything here. Hold tight. Okay, let me finish that up. And we'll test the radio again, see what the difference is. Okay, I think we're all set here. Yeah, my furnace came on. And I didn't want that to come on. I'll run and reset my thermostat, make sure it doesn't come on. It's too warm to be running a furnace. Okay, that's what I say. Wait a minute, isn't there a thermostat? Doesn't that decide? No, I'm in charge, not some silly thermostat. Okay. Volume down. We don't know what's going to happen here. So dim bulbs in view, and we will start with one dim bulb for some reason. I'm super chicken today. Here we go. Okay, nothing bad happened there. Volume's right down, so we shouldn't hear anything. If it doesn't work, it's thumbs up. Okay. Let's turn it up. What's it do? Don't do nothing. Doesn't do a darn thing. Uh-oh, uh-oh, uh-oh. How did that happen? Watch out for something bad happening now. I don't think so. I can't believe that didn't work. Unbelievable. Signal tracer. Okay, single point of grounding. Remove this connection here. Put the signal tracer onto there. There. Signal tracer to the volume control. So the output of the volume control should be right here. The output of the radio, rather, should be right here. We're on audio. Don't hear a thing. Don't hear a thing. Don't hear a thing. Nothing. Okay. This didn't work out good. I'm moving the capacitor now. I'm letting DC go through the volume control. So if the arrangement is wrong, even though it matches the schematic, then we could cook the volume control while I'm fooling around here. Maybe. I don't get this. There's no output from the radio. Why is there no output from the radio at all? Do I have an antenna connected? Yes, I do. It's very close to grounding out by accident there. What has gone wrong? Okay, let's go back up the radio. Input. What was that momentary beep stuff? Okay, we're gonna reconnect this. It's the only thing I have grounding in the radio. Leave this hanging here. Put this here. Try it again. Could that make a difference? Yeah. So now we're hearing the hum across this resistor right here. It's not helping much. Doing it like that, we're better off on the B minus, I think. Mr. Radio, what happened to you? You were humming along there. Well, no, you were, literally humming along. And now you've decided to check out. How can this be? What is it I didn't see? So if we analyze the volume control direction, I thought, well, I got to turn it right around. So this is turning it down. Okay, so if that's turning it down, the wiper is coming around this way. It's coming to the ground terminal. If it comes this way, it's coming to the input terminal. What I think is the input terminal. Hey, is this thing making any? Why? Why have you gone so quiet? I mean, it's really quiet again. Zero coming out of that speaker. Oh, son of a gun. Well, what happened? Did the B plus go away? Have I shorted something out? Well, it'd be kind of obvious with the dim bulbs. They're still in the circuit. Dim bulbs still in the circuit. Voltage on the radio 107. Hey, what's going on? Did I not put did I take a capacitor out and not put one in? I've only done 2 today. There's 2 in there. There's no sound coming to the volume control. There's no sound coming out of the radio. Did I blow a tube out? Did I? We want to measure the B+. Let's remove this ground. This is the meter ground over here. Do I sound like I'm rushing? I am rushing. I think something bad is happening here. I need to find it quickly. If it was really bad, well, we'd know about it already. So it can't be really bad. So we got this positive. This is on the 150. Is there B+? There's no B+ in this radio. There's no B+. Check it again. Maybe that's a grounded in? No. This is not moving at all. Show me some voltage here. Here. Oh. Okay, so that's 150 volts here. How come not over here? Oh no, that's a bypass. Is that a bypass? No. This is not a bypass. No. Jim, you're getting too excited here. How about this guy? He's got nothing. That sounds like field coil open. You got the voltage on one side. Lots of voltage. We've hooked up a wire wrong. And over. Now this is the bypass capacitor, so we don't care about that one really too much. This big resistor on the other side of it. There's nothing. Wow, these are talking about shorts. Wow, is that ever close? Huh. I think it was just saved. Now, is that likely to be the problem? I doubt it, because I can still see voltage here. We'll get back on it. It's kind of weird. What is it? This must be the heater resistor, and this one in here must be the B plus resistor, or the power supply resistor. So one side of the power supply resistor goes here. Nothing. What happened? Did the rectifier tube crap out right in the middle of this? The other side. Wow. Can I get in there? I can't really. It goes right in. It's another. That sounds like a loose wire to me. What did I touch? Found it. Okay, we found a cold solder joint. This one? Sure doesn't look like it. This one? I don't know which one it was. Could be one of these. We'll solder them all up. Wow, none of them feel loose. Resolder them all. Okay, that's what I'll do. Whew. I'm sweating a lot now. A little overdressed today. I'd rather be a little hot than a little cold. That's my old age showing up. So we'll just do every one of these 4 wires. 2 of them are the field coil, which is the one that's in trouble. Well, I know which ones are the field coil. Whew. I should have spent more time identifying exactly which wire it was. Now I'm probably inserting another bad solder connection. Actually, you know what? This one doesn't look so good. Everything's melted. Okay. Use this one. That's it. There it is. That's the one right there. I didn't solder it. Unsoldered wire. Da da da. Da da da. Well, okay, positive. We have found the problem. We have found the problem, and it is me. Looks like I soldered it, but that's got to be the problem. Give it lots of solder. Are you hanging from one strand or something? Long wire here. Lots to work with. These wires are terrible to strip. These cloth covered wires. Ooh, lovely job. see. You can't see what I'm doing. Terrible. Terrible job. Terrible. This is just terrible. I'm just gonna sink it in the solder here if I can. Again, I can't see what I'm doing. That's poke my finger. Okay, calm down. Calm down. Take the stuff out of your hands. Slow down. Think about what you're doing. What are you rushing for? You got somewhere to be? No. Something you'd rather be doing? Well, not so much on a rainy day. Cup of coffee waiting. This has got it soldered now. Oh, it flipped off. Just as I said that. Okay, I'm happy with that. Finally. Okay. Radio ready to start again. Do your work. Or have I booped it up somewhere? Okay, so we have the voltmeter connected, but we probably don't need it. Separate that. Let's take this right off here. Okay, we are free and clear. Here we go. The number of times I found radios with errors in them is very, very limited. Just a couple of times have I had a radio where somebody tried to do away with the rectifier tube, and I ended up restoring it all back and putting a rectifier tube in. Lots of volume. Too much. What's going on there? I think that was a coincidence. Loose two. I don't think so. So there's a sudden change in performance a couple times. It seems like it's too loud. It's too hot. Well, we still got 2 more capacitors to do. Maybe that'll clear it up. I don't know. But boy, if you're looking for a radio with some volume, here's your baby. I didn't even turn it up. Very good. Okay, that's good for today. I'm pretty sure I did the right thing here by switching this around. I'm pretty sure they had it backwards. It's a really quite surprising thing. By the way, the radio that I worked on that had the worst stuff in it. What's my computer doing here? It's doing something weird. The radio that had the worst user mistakes in it was my own radio, great big military radio, an SP600, and I guess maybe when I was in my 20s I'd done work on it and made a lot of mistakes, and found them here in my shop years and years and years later, and they were dragging down the performance of that fantastic radio. It's a fantastic radio. Not anymore though. I mean, it's now a really fantastic radio because I corrected those problems. So I am the worst actor when it comes to making mistakes that I've encountered. So okay, that's it for today, and thank you very much for watching. Tomorrow I'll knock off the last 2 capacitors, and then we'll try to see what's going on with this little bit of a weird behavior here. Perhaps the person who made these changes made more changes in here that I don't even know about yet. I don't know. Thanks a lot for watching, and see you tomorrow.